3, 2, 1, 0.
When you think of NASA, you probably think of this. But as soon as we made it beyond the limits of our atmosphere, one of the first things we did was turn our cameras around and look at this. The first U.S. satellite was launched in 1958. That's 11 years before Neil Armstrong became the first person to walk on the moon. Explorer 1, built at the Jet Propulsion Laboratory, initiated a long legacy of satellites meant to take our understanding of Earth to new heights. In 1997, NASA launched a satellite that began a 20-year continuous global record of the very thing that, as far as we know, makes Earth special: life. While most satellite missions capture data on the physical characteristics of our planet's climate and weather, others allow us to measure life itself. The result? The most complete view of global biology to date.
The greatness of this data set is kind of hard to explain. It allowed me to understand ocean in such an organic way.
That's the voice of oceanographer Dr. Ivona Sitinic. Ivona and the rest of the NASA Goddard Ocean Ecology Lab help oversee the 20-year dataset. If you take a closer look at this animation, you'll see what looks like a repetitious ebb and flow on the land and surface of the ocean. We're actually watching the planet breathe.
About half of the total photosynthesis on the planet occurs on land and half in the oceans.
That's Dr. Compton Tucker, who pioneered satellite monitoring of vegetation on land. The spring and summer months kick off the growing season for plants on land, illustrated in dark green, and tiny microscopic plant-like organisms in the ocean called phytoplankton, seen in the light blue. They take carbon dioxide out of the atmosphere and use it for energy, causing the total amount of carbon in the air to drastically drop. The opposite is true during colder months. During winter in the northern hemisphere, which is home to most of Earth's land plants, carbon in the atmosphere increases as plants go dormant. And then there are extreme zones in the ocean. Purple patches are nearly devoid of any phytoplankton. They're basically deserts at sea, while the red zones tell us that there's either a high concentration of phytoplankton hugging the coastline, or our satellite sensors are picking up on another input changing the color of the water.
We have a marvelous biological diversity of plants and animals, both on the land and also in the oceans.
But hold on. If we have an amazing biological diversity of plants and animals, why do scientists spend all of their time observing plants?
You know how they say you are what you eat? In the same way, if we want to understand the ocean and life in the ocean, we have to start from the base. If phytoplankton is changing, the whole ecosystem will change.
The changes that Ivona is talking about are much easier to see when we can study a continuous global record. And that means not only being able to look into the past, but also into the future.
It's this long-term data set allows us not only to see exactly what's happening, but to be able so much better way to predict what's going to happen.
A global perspective gives scientists the power to forecast events like harmful algal blooms, disease outbreaks, and even famine. Maybe one of the most useful applications of the data is its ability to show us where we've been. In 20 years, the planet has changed in noticeable ways, and this dataset gives us a visualization to prove it. Arctic greening coupled with retreating Arctic sea ice are probably one of the most well-known examples of this.
If you look at the higher northern latitudes, you see in the white where there's snow, and that then moves further north and recedes. It's then followed by very, very green colors because plants are really photosynthesizing in those dark green periods.
Scientists think that there are likely trillions of planets, yet Earth is still the only planet we know of with life. And with that in mind, our habitable homeworld seems ever more fragile and beautiful when considering the vastness of unlivable space.
I have several friends and acquaintances who are astronauts. They all say the same thing. When they're in orbit, on the space shuttle or in the International Space Station and look down at the Earth, they see one climate, one planet. We're all in this together, and we need to work together to make sure that life as we know it continues on this wonderful planet.